Lesson 10.6 is on trigonometric ratios. Okay, in this video you're going to learn to find trigonometric ratios of angles and also use trigonometry to solve triangles. Okay, this section has a lot of vocabulary, so if you want to pause your video now and start writing those down. Okay, so we are going to learn about sine, cosine, and tangent. You may have seen these before in, math problems if you've seen a more advanced thing. They're constantly used, so they're important to know. So right now we're just going to learn some of the basics, okay? So what they're saying is there's this operation called sine, cosine, and tangent, okay? So the operation sine, if you take the sine of an angle, the capital letters represent an angle and the lowercase letters represent a side, a length of a side. Okay? So if you have an angle A in a right triangle, these only work for right triangles. Okay? That means that the ratio of the sides, the side over here and the side here, A and C, are going to give you the equivalent of taking the sine of the angle. Okay? Now, sine is always the side that's opposite the angle. So if I'm over here, the side that's opposite is going to bring me here. So it's going to be this side here. And then it's over the hypotenuse. The hypotenuse, remember, is the side that's opposite the right angle. It's the longest side of a triangle. Okay? So sine is going to be opposite over hypotenuse. Okay? Cosine is adjacent. The adjacent means next to. So if I'm taking the cosine of A, I'm looking at the side next to it that's not either one of those. It's not the hypotenuse. It's the other one that's next to it, not the hypotenuse. In this case, it's B. B is my adjacent to A, okay, over the hypotenuse. So cosine is adjacent over hypotenuse. Okay. Tangent is opposite over adjacent. So if I'm looking at A and I want to know what is tangent of it, I'm saying the opposite side, so A, over the adjacent side, B. Okay? Now, we can't use opposite, hypotenuse, and adjacent with the right angle. It's only with the other two angles in a right triangle. So I can do the same thing with B. And I could say, okay, sine of B, sine is always opposite over hypotenuse. So opposite of B in this case is B. And the hypotenuse is still C. Okay? If I were to do cosine of B, that's adjacent over hypotenuse. So the side next to B, that it would either be A or C, but C is the hypotenuse, which means the adjacent side must be A. So adjacent, okay, is going to be A over the hypotenuse, which is C. And then that means that tangent of the angle B is going to be opposite over adjacent. So opposite of B is the little b, and then adjacent to it is A. So those would be my sine, cosine, and tangent for B, and then what we had here in the thing was for A. Okay. So we want to find the values of the three trigonometric ratios for the angle B. So I'm looking at this angle, which means when I do my sine, you remember that, not sim, sine is opposite over adjacent, okay? There's a thing that some people like to use. They like to use a way to represent that. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, if you were to read this out, it would be so, ka, toa. And so people remember SOHCAHTOA, and it helps them remember which one goes with which. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So when I do my sine of B, it's going to be equal to my opposite side over my hypotenuse. So opposite of my angle B is 12, and my hypotenuse is 13. Now when I go to do my cosine of B, it's adjacent over hypotenuse. So my side adjacent to B is this little b, but I don't know the value of that little b. But I do know the two other sides of a right triangle. So I can use my a squared plus b squared equals c squared my Pythagorean theorem to figure out what b is. So I know my a is the 12. I know my c is 13 squared. So I'm going to get 144 plus b squared equals 139, I believe. So 140, no, that's not right. I lied. It is not 139. 13 squared is 169. Yes, it's 169. So then when I subtract 144 over to the other side, I'm going to get b squared equals 25, which means that b is then going to be 5. So I know that this side here is 5. So now I can do my cosine, which is adjacent over hypotenuse. So it's going to be my adjacent side is 5 over my hypotenuse is 12. Okay, and then I can do my tangent of b, which is opposite over adjacent. So opposite b is 12, and adjacent to it, the one that's not the hypotenuse, is 5. So 12 over 5. And these would be my 3 trigonometric ratios for angle B. Okay, the next thing that you want to be able to do is use a calculator to just figure out what this is equal to. So I'm going to show you in class tomorrow, but really you're just finding the tangent button and putting in 52. So if we were to do that, we would get 1.28 about. So if you guys want to play with your calculator and see if you can figure that out, if not, we'll go over it in class. Okay, so in this case, they want us to solve the right triangle. When they say solve the right triangle, that means they want to know what all of the sides are and what all of the angles are. Okay, so if you remember from previous classes, all of the angles inside of a triangle add to 180. And we know that this angle here is 90. So if I want to figure out what this angle here is, I'm going to do 180 minus 90 minus 162. So if I do 180 minus 90 minus 62, I'm going to get that this angle here is going to be 28 degrees. Okay, so I got all my angles, which means I still need to figure out some of my sides. Okay, so I want to use one of my angles, either the 62 or the 28. Remember, we're not going to use the right angle. It doesn't work for our sine and cosine. So I want to use one that relates the 14 to one of the other sides, so that my only unknown is going to be a. Okay, so let's do 62. And I want to do opposite and adjacent so that I can figure out what a is. So I'm going to use tangent. So I'm going to do tangent of 62 degrees. That's what's in my angle B. And then opposite is 14 over the adjacent is a. And then I want to solve for a. So I'm going to multiply both sides by a. And I'm going to get a times tangent of 62 degrees equals 14. I'm going to divide both sides by tangent of 62 degrees equals 14 over tangent 62 degrees. So whatever this comes out to, when I do this, that's going to be my A. So if I do on my calculator, tangent of 62 is negative 1.09. So if I do 14 divided by that, so I'm going to do 14 divided by negative 1.14, just negative 1.1. Okay, so plugging this into my calculator, I'm going to get A is equal to 12.7. Okay, so I know that this side then is going to be 12.7. Now I have two sides, and if I want to find the third side, I can go back to using the Pythagorean theorem. Okay, so after plugging all of that in, you should get that C is 18.9. If you need to pause your video and look at the work, you can do so. But for the sake of time, I skipped it. Okay, so you guys try this one. Okay. A conveyor belt moves recycled materials from station A to station B. The con the the angle and the conveyor belt makes with the floor of the first station is 15 degrees. The conveyor belt is 18 feet long. What is the approximate height of the floor of station B relative to station A? Okay, so we want to know what H is. Okay, and we know what this is, and we know what this is. So we want to know, we know what angle A is. We want to know which trig function relates the side that's opposite and the hypotenuse, and that's going to be sine. So I want to use sine of A equals opposite over the hypotenuse, and I want to fill in all the values I know. I know that A is 15 degrees. I know that the opposite side, in this case, is H, and my hypotenuse is 18. So now if I want to solve for H, I want to get rid of this 18. I'm going to multiply both sides by 18. So I'm going to get 18 times sine of 15 degrees is what my height is going to be. So you're going to put this into your calculator. So you're going to do 18, well, let's start with sine of 15. And then I want to multiply that answer by 18. And I'm going to get that my height is 11.7. And these are in feet, this is feet. Okay. Okay, then we want to get into inverse trigonometric functions. So, if A is an acute angle and the sine of A is x, then the inverse sine of x is the measure of angle A. Okay, so let's say I'm given two sides and I want to know the angle. This is when these come in handy. I do the inverse sine. Okay, so for example, here, if I want to know the angle P, okay, if I want to know the angle P, I have the two sides, but I don't have the angle. That means if I have sine of P, well, I don't want to use sine. I have the adjacent side and I have the hypotenuse. That's actually going to be cosine. So I want to have cosine of P is adjacent, which is 22 over 24. So if I want to know what P is, that means I want to get rid of this cosine. That's when I do the inverse cosine. So I'm going to say P is the inverse cosine of 22 over 24. And again, if you don't know how to find this on your calculator, I'll show you tomorrow. But for now, I just wanted you to see how this would work, and we'll get into this a little bit more in class. Okay, so I'm going to stop there, and we'll do some more practice in class.